So now let's do an example with polar. So let's say the polar example has r equals 7 plus 3 sine of theta. In the UR direction. And then we're given that theta equals t over 2. So then we want to find velocity and acceleration. So we can use the formulas that we have worked out already. We know that v equals r dot ur plus r theta dot u theta. Because we worked out that formula before, but we need to know what are r dot and what are theta dot. So over here, we can have r. We know that the r is going to be this part, this whole thing in parentheses. 7 plus 3 sine of theta, which is t over 2. And then we know that theta equals t over 2 because that was given. So we just take the individual derivatives of these and plug them into the formula. Theta dot equals 1/2. R dot equals, derivative of 7 is 0, so we'll just have 3, but we use chain rule here, 3/2 cosine t over 2. So we just take each of these and plug them into this formula. So v equals 3/2 cosine t over 2 UR plus 7 plus 3 sine t over 2 times theta dot, which is 1/2, u theta. So this is the velocity equation. You can also simplify this and write it as 3/2 cosine t over 2 UR plus 7/2 plus 3/2 sine t over 2 u theta. We just distributed this 1/2 to both of the terms inside. So then you could put, if it asked for position or velocity, whatever, at a specific t, then you just plug that right in. Now to get acceleration, we take, let's see, well, we know from our acceleration formula, we will have r double dot minus r theta dot squared UR plus r theta double dot plus 2 r dot theta dot u theta. Well, we have the r dot theta dot, but we need to get the double dots. So we go over here, we take the derivative again. Theta double dot, well, derivative of 1/2 is just 0. So that'll be nice and convenient. It'll cancel this term. And then r double dot is going to be, take the derivative of this, and because of chain rule, another 1/2 pops out, so we'll get 3/4 sine t over 2 but derivative of cosine is minus sine, so this is a negative. So we take those and we plug them in down here. So in this part, we'll have r double dot, which is that minus 3/4 sine t over 2 ur plus, remember, oh yeah, sorry, we need to do that, the theta dot part. Okay, so we got the r double dot, and then we need to do minus r times theta dot squared, which is 7 plus 3 sine of t over 2. And theta dot squared is 1/2 squared, which is 1/4. So all of that is in the UR direction. And then plus, we want to get the U theta, we'll have R theta double dot, which fortunately for us is going to be 0 because theta double dot is 0. So anything times 0 is still 0. So move on to this part, 2 R dot, which is 3/2 cosine t over 2 times theta dot, which is 1/2 u theta. Now this is kind of long and junky looking, so we'll simplify it a little bit. We'll have negative 3/4. Okay, so we'll have sine t over 2. Actually, let's get rid of that. So let's see, what do we have that's times sine of t over 2? So we'll have sine t over 2 times, we got this negative 3/4. And then also that's going to be minus, there's another 3/4 here because 1/4 times 3. So that's going to be times negative 3/2. And then here we'll have the minus 7 divided by 4. And here the 2 and the 1/2 cancel. So we'll just have plus 3/2 cosine t over 2 u theta. Now let's say we want to put numbers in. Say we want to find an initial, t equals 0. So if we're finding it for t equals 0, we just need to plug 0 in to everything. So over here, b of 0, well, if you plug 0 in here, cosine of 0 is 1. So we'll just have 3/2 ur plus sine of 0 is 0. We'll just have 7/2 u theta. That equals 1.5 ur plus 3.5 u theta. And this is going to be, we'll say that's meters per second. This is meters. And acceleration is meters per second squared. So then we get acceleration, a of 0, just plug 0 in down here. So we'll have sine of 0 is 0, so we get rid of this. And then we'll just have minus 7/4 ur, and then plus cosine, so plus 3/2 theta, which equals minus 1.75 UR plus 1.5 U theta meters per second squared. So to recap what we did here, for polar coordinates, we have to remember that the unit vectors also change. So you can take their derivatives or use those formulas, and then you take derivatives of r and theta separately, you plug them into the formulas, and then if you have numbers, you plug in the numbers. So procedure, identify which coordinate frame. So figure out which coordinate frame to use. Second is take derivatives. Three is plug in. So 3 steps: identify the coordinate frame, take derivatives, plug stuff in.